All right, let's talk about something really cool today. We're going to dive into a technology that's basically giving factories a virtual co-pilot, a digital partner that lives right inside the machine. Yep, we are talking about digital twins.
But first, just imagine this for a second. What if you had a crystal ball for your most complex, most expensive machinery? What if you could see a massive breakdown coming, like weeks in advance, and fix it before it even had a chance to bring your entire production line to a screeching halt? Sounds like science fiction, right? Well, it's not. This is the exact problem that digital twins were born to solve.
You see, any modern factory floor is a super high-stakes game. Every single minute of unplanned downtime can cost a fortune. Every little inefficiency just bleeds money, day in and day out. For years, engineers have been battling these, let's call them ghost problems. Those invisible stresses on a machine, the bottlenecks you can't see, and that constant costly trial and error of trying to optimize a system while it's already running flat out.
So what if you could fight those ghosts in a whole different dimension? And that's exactly where our hero, the digital twin, comes in. It is the perfect weapon against these invisible, expensive problems. It gives us a way to see, to test, and to perfect everything in the physical world, all from the safety of the virtual world.
Okay, so what is a digital twin? Really, let's nail down a definition. At its core, it's a virtual replica of a physical thing. But here's the absolute key. It's constantly fed real-time data from that physical thing. This isn't just some static 3D model or a dusty blueprint. No way. This is a living, breathing digital copy that is dynamically, instantly linked to its physical counterpart. It changes when the real thing changes.
Now, digital twins didn't just appear out of nowhere. They're the result of a long evolution. I mean, we started with basic CAD models, which were just static geometry. Then we got simulation models, which let us do analysis, but it was all offline. After that came cyber-physical systems, which started to integrate the physical and digital. But the digital twin, that's the final leap. It's all about that real-time, bi-directional interaction. It's a constant two-way conversation between the real world and the virtual world.
It might sound a bit like magic, but I promise you it's just a really clever system of engineering. So let's pull back the curtain and take a look at the mechanics behind this virtual co-pilot. How does it actually work, moment to moment, out there on the factory floor? To really get it, you've got to understand what it's made of. A complete digital twin system really just boils down to a handful of core components, all working together perfectly. Let's break them down.
So it all starts with the physical asset. The actual robot, the machine, the whole plant. Then we create its virtual model. Next, we cover the real machine with all sorts of sensors, IoT devices, to capture everything: temperature, vibration, speed, you name it. That data then flows through a communication layer, like a super fast data highway, straight to the brain of the operation, the analytics and intelligence engine, where AI crunches all those numbers. And finally, and this is the most important part, that feedback loop sends insights and actual commands right back to the physical machine, telling it how to improve.
And this process creates the engine that drives the whole thing, this continuous data loop. It's a constant, flowing conversation. Look, the machine operates, the sensors grab the data, and that data gets zapped over to the virtual model. The twin then runs thousands of simulations. It analyzes performance, it predicts what's going to happen next, and based on all that, it generates optimization decisions and, here's the magic, it sends those decisions right back to the physical machine to actually implement them. It's a cycle of never-ending improvement.
Okay, theory is great, but what does this actually look like in the real world? Let's talk about how digital twins are already delivering huge, tangible results in actual factories, completely changing the game for how they operate.
Right. One of the biggest and most valuable uses for digital twin tech is something called predictive maintenance. It's basically the art of fixing something before it breaks. And believe me, for manufacturing, this is a total game changer.
This quote really just says it all. Picture a critical motor on an assembly line. Its twin is sitting in the cloud, constantly analyzing its vibration patterns. Long before any person could possibly hear or feel a problem, the twin notices a tiny, almost imperceptible change in those vibrations and calculates that a key bearing is going to fail in exactly 3 weeks. Now, that's not just a warning light. That is a scheduled, low-cost repair instead of a catastrophic, line-stopping disaster.
And when you can do that, the benefits just start stacking up. You get super early fault detection, you can accurately estimate the remaining useful life of pretty much any part. All this leads to a massive drop in that dreaded, unplanned downtime. And of course, it just slashes your maintenance costs. You're not just reacting to problems anymore, you are actively managing the health of your entire factory.
Now let's look at another huge area, robotics. Industrial robots are the absolute backbone of modern factories, but getting them to work perfectly can be a super complex and time-consuming process. Digital twins are giving these robots a massive intelligence upgrade.
So, in a robotic work cell, engineers can now use a digital twin to program and test literally everything offline in the virtual world. They can run scenarios to check for any potential collisions without risking a multi-million-dollar piece of hardware. They can run thousands of simulations to find the absolute perfect path for the robot's arm to move, shaving precious seconds off of cycle times. And they can do all of this before a single physical robot even twitches.
Now you might be sitting there thinking, okay, but isn't this just a really fancy simulation? And that is a great question. This table clears it up perfectly. A basic simulation, that's all offline, no real-time data. A digital shadow is getting warmer. It gets a one-way stream of data, so it can monitor what's happening. But the true digital twin is unique because of that two-way data flow. It doesn't just monitor, it controls. It doesn't just watch, it acts. That is the critical difference. So when you put it all together, the value here is just immense. On the technical side, you get real-time visibility and reliability like you've never had before. Economically, the payback is obvious. Less downtime, lower costs. And operationally, it means you can set up new lines way faster and have so much more flexibility to change things on the fly. It's a win, and a win.
So, we've seen what digital twins are doing right now, but where is all this headed? I mean, the technology is still evolving pretty fast, and its future is, frankly, even more exciting. So, let's take a peek over the horizon.
But first, let's be realistic about the hurdles. This isn't some simple plug-and-play solution you buy off a shelf. Getting started requires a pretty high initial investment. Stitching together data from hundreds of different systems is incredibly complex. You have to constantly make sure your virtual model is accurate. And of course, you need skilled people and rock-solid cybersecurity to manage the whole thing.
But the future trends are absolutely mind-blowing. We're moving toward AI-powered twins that can literally learn and adapt all on their own. They're going to live on the cloud and at the edge, making them way more accessible. Imagine an engineer wearing augmented reality glasses, physically looking at a machine and seeing all of its twins' data overlaid in front of their eyes. We're even seeing twins being built to optimize for sustainability, to minimize waste and cut energy use. It's incredible.
And all this leaves us with one last fascinating thought. We focused on the factory today, but this idea is exploding outwards to entire smart cities, to global supply chains, even to the human body for personalized medicine. So the real question we're left with is this. As our physical and digital worlds keep merging together, what won't have a digital twin? The possibilities are just staggering to think about.